Okay folks, welcome back. This is part 2 of the Terrestrial Escape Rocket Project. Today we are going to do cooking and casting of fuel. And what you have in front of you here is a skillet that I use to do all my cooking, 2 spoons to help with the casting, a spatula, and a knife for scraping and remixing fuel. Hot water here for getting the fructose corn syrup out of the cup. In the cup I have about 75 grams of fructose corn syrup, and the white container here is the mix, a 65-20% mix, 65% potassium nitrate and 20% of sugar. A little bit further over is the casting tray that I have, several coring rods, several molds that I use to cast the fuel into, and a couple coring tools right here, which you'll see more of very shortly here in the video. I also have some lubricant spray here. This helps to remove the fuel from the coring rods, and just a very simple container over here to put the fuel in once it's done. So we're going to get right at it. No heat on the skillet as of the moment, but we'll get that started and get some fuel cooked here. I usually start cooking fuel at a temperature of about 250 degrees. Off and on throughout the video I'll adjust the temperature. You don't want to cook it at too high and have the fuel caramelize, and cooking it too low will just absolutely take forever, so we don't want that either. I'm going to start by combining the hot water. This is about 100 milliliters of water that I'm going to pour into the fuel and into the pan. Just a quick mix. And what this does here is it actually frees up the corn syrup from the cup, otherwise it would be very sticky and you would never get the 75 grams of fuel out of it. Doesn't take long. So that part is done. We can just set that to the side. I do not dump all of the fuel right into the pan right away. I'm a bigger fan of mixing it in, and once it has turned to more of a slurry, I'll put more in. It takes a few extra minutes, but I find that it's worth the time. This is not, by the way, the typical R-candy mix. The R-candy mix typically has a 65% potassium nitrate, 35% of whatever type of sugar you're using, and about 7% of some sort of binder like the fructose corn syrup. This is somewhat of a hybrid between Jimmy Yon's recrystallized and Dan Polino's Flexi Fuel. I've tried all three. Flexi Fuel is very quick, very easy. A friend of mine, Rocketman BKK, is a huge fan of the Flexi Fuel. It works very, very well for him. I just, over the course of time, become much more partial to this. The purpose of having this much water is really only to further break down the pieces of potassium nitrate and the sugar. If this was real recrystallized fuel, it would be 100 milliliters of water per 100 grams of fuel. This is going to be 500 grams total. So if I were going to do this as recrystallized, what we would have is 500 milliliters of water. As of right now, there's only 100 in there, and that's all there's going to be. Now this process takes upwards of 35 to 45 minutes depending on how the cooking is going. So what I'm going to do is just do the video in segments. There's no sense in you watching the same thing going on over and over again. But I'll get to the point where the fuel is in a slurry, it's all dissolved into the water, and then we'll check back periodically just to check on the process. We'll do it in, say, 10-minute increments. I often find that having a higher heat, starting off at 250 just to get your corn syrup not at a boil but at a simmer, and then raising the temperature up to about 300 once you've got the process going, works really well. I do find myself occasionally backing off on the heat. I ruined one batch completely by having the heat too high too early in the process, and all it did was end up making a very flaky type of fuel. I did have several big chunks of fuel left over from previous batches that I was able to mix in and able to salvage the fuel, but then I had 1,000 grams of fuel on my hands, and it's about right for a low K-class rocket. Upper J, lower K-class anyway. But in my area I have very, very little use for that powerful of an engine. That's someday when I have a better, happier launch field to work out of. So as you can see, we've got this at a simmer. You can even see it starting to, the slurry to turn into a that's kind of a gel on the top. That's exactly what we're looking for. Not so hot that it will boil, not so cold that it won't effectively break down the chemical mixture. I'm just going to put the rest in. This simmer into bubbles right now that you see is not a heat that you want to maintain through this cooking process. Again, if you were to do something like that, the heat is too high. It would ultimately end up in making that very flaky fuel that is very hard to cast, and I would almost imagine is dangerous because it wouldn't cast into a solid fuel. It would be very flaky, probably have pockets, and in high power rocketry you want to avoid that. You're much more likely to cause a KO in your motors if you have air pockets in your fuel, or something flaky that would burn rather quickly. Most of the motors I make are I-class, 375 grams of fuel, sometimes less, and they burn out within a second and a half. So it's a quick burn as it is. Mixing and mashing is a very essential part of this whole process. I do pre-mix my fuel as far as the potassium nitrate and the sugar go. I use confectioner sugar, by the way. You can either use regular table sugar or you can use confectioner. I haven't seen a huge difference in either or, but the confectioner sugar is very, very easy to work with. It's essentially already broken down. Works as a great oxidizer. Almost there. Still a couple of chunks left. When I see chunks like that, I just kind of mash it in. The water tends to want to creep out to the edges, so you just want to bring that back in. And there you have it. It's a non-stop process, again of 35 to 45 minutes, scraping the excess fuel off the sides and back into the center. So my recommendation is grab a nice hot cup of coffee, settle in for the 35 to 45 minutes of doing the same thing over and over again, the mixing and the mashing, and the payoff will be a very great, very usable fuel. So we're at the point now where I can pause the video and we'll check back in about 10 minutes. Give you just a quick shot of what this looks like up close. So there it is. Looks like mashed potatoes about at this point. The fuel is pretty much broken down into very, very fine pieces, very few granules left, and over the cooking process those will melt and combine, and we'll start looking at casting some fuel in about 35 to 45 minutes. Okay, so we're back. It's about 15 minutes since the first segment of this video. As you can see, this fuel is already in a very different form. It's gone from being a very easy slurry to move around to a much more thick composite, and I would say by the texture of this that it's going to be ready in about another 15 minutes or so. So just a quick update, we might end up doing a snap test, we may not, depending upon how long this video is going to end up being, but there you have it right there. It's almost done, almost ready to cast.